Hello, 7th graders. Welcome to 3.8, which is on solving equations containing fractions. Today, you're going to try to solve one-step equations that contain fractions. This is very similar to solving equations containing integers, what we did last chapter. And now we just have to remember the rules for integers. So, is it positive? Is it negative? What are those rules? And also the rules for fractions. So how do you multiply fractions? How do you divide fractions? We're putting it all together now, okay? So try to keep all of those rules and methods separate for this section, okay? Let's start with example 1 and see what we're dealing with. It says x minus 3/7 equals 5/7. So what number, when you take what number subtracted by 3/7 will give you 5/7 is what this is asking. Okay. Remember that one of the best things to do in equations is split it down the equal sign and ask yourself, what's being done to my variable? Well, in this case, x is being subtracted by 3/7. So to undo that, I would need to add 3/7 to both sides of my equation. Okay, so I'm going to use the addition property of equality to essentially cancel out subtracting 3/7. So I'm going to add 3/7 to both sides of my equation, because subtracting 3/7 and adding 3/7 are the opposite, and they cancel out, so I'll just be left with x here. And then on the right hand side, all I need to do is add. Well, what's nice here is that I've already got a common denominator of 7, so I'll keep my common denominator and then add my top two numbers. So 5 plus 3 would give me 8/7, and I'll write that as a mixed number. 7 goes into 8 one whole time, and there's 1 left over to get to 8 and keep my denominator of 7. So 1 and 1/7. Let's just double check. Let's substitute back in 8/7 to my original equation. If I put in 8/7 for what I found x was, and I subtract 3/7, does that give me 5/7? Well, yeah, keep your common denominator, and 8 minus 3 is 5. Okay. For letter B now, we'll have to use a different property, because I see right away that we're adding. Okay, so I have 4/9 plus something is going to give me negative 1/2. All right, so to undo adding by 4/9 on this side to get r all alone, I'd have to subtract 4/9 on both sides. So I'm going to use the subtraction property of equality. Okay, just to undo this 4/9. So I'm going to subtract by 4/9 on both sides. All right, 4/9 minus 4/9 on the left-hand side cancels out. I'll be left with r. And then I just have to take 1/2 and subtract 4/9 on the other side as well. Okay, so let's write this out. I've got negative 1/2 minus 4/9. First thing, when I'm adding or subtracting fractions, I need a common denominator. And I have 9 and 2, I could get them both to 18ths. So 1/2, and it's negative 18ths. How'd I go from 2 to 18? Well, I multiply by 9, so I'll do the same here. I'd have negative 9/18 minus, I'm subtracting, and I need to put this 4/9 into 18ths as well. So I need to multiply by 2. So 4 times 2 would give me 8. Okay, so I've got r equals negative 9/18 minus 8/18. I found a common denominator. Okay, now let's look carefully at this subtraction problem. I've got a negative number minus a positive number. Remember, the easiest way to subtract integers is to change your subtraction to addition and the next number to its opposite. In other words, chop, chop. Perfect. Now I have negative 9 and I have negative 8. When I add negative 9 and negative 8, I just add the two numbers and keep the sign. Okay, so 9 plus 8 is 17, and I keep the negative sign. Negative 17 and the denominator is 18. So negative 17/18 is my final answer. Again, don't forget about chop chop. And then when you're adding two numbers with the same sign, they're both negative, you just add them and keep the sign. All right? Let's move on to the second example now, where we'll see a multiplication problem. It says solve and write each answer in simplest terms. I've got 3/8 times what number times x equals 1/4. Well, again, ask yourself, what is being done to your variable and how do you undo it? Well, 3/8 is being multiplied by, or x is being multiplied by 3/8. So to undo that, I would divide by 3/8. And I would have to do that on both sides. Divide this by 3/8 as well. Okay, so 3/8 divided by 3/8 is 1. Anything divided by itself is 1. And then I just have to take 1/4 divided by 3/8. Okay, remember now, use the handy dandy little acronym that I gave you last section of keep, flip, flop. Keep the first fraction the same, flip your division to multiplication, and flop this to its reciprocal. So that would be 8/3. Again, multiply by the reciprocal of 3/8, which is 8/3. All right, I'm going to simplify before I multiply. Looking diagonally, 4 and 8 have a common factor of 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And now I can multiply across. 1 times 2 gives me 2, and 1 times 3 gives me 3. So I come up with a total of 2/3. If you want to double check that, take 3/8 and multiply it by 2/3, and you will come up with 1/4. Okay. Flip to the back side for letter B, and we'll have another fraction problem in an equation. This one says 4 times y equals 8/9, right? What is being done to y? It's being multiplied by 4. So to undo that, I would divide by 4 on both sides of my equation. Well, 4 divided by 4 is 1y. It cancels out. And then I just have to take 8/9 divided by 4. And 4 as a fraction is 4/1. Okay. Then keep, flip, flop when you divide fractions. So 8/9 times, change division to multiplication, and flop this to its inverse, which is 1/4. I will simplify first. So I'll divide each of these by 4, which will give me 1 and 2. And then if I multiply across, 2 times 1 is 2, and 9 times 1 is 9. So I'll come up with a total of 2/9. Again, we just multiplied by the reciprocal of 4. It was 1/4. Okay, so y equals 2/9 is your final answer. All right, in example 3, moving on, looks like I'll get there in the next video. I'll be right back. Okay, example 3 says the amount of copper in brass is 3/4 of the total weight. Reminder that of in math means multiplication. Might be a good reminder to write in there. Of in math means multiply. If a sample contains 4 1/5 ounce of copper, what's the total weight of the sample? Well, okay, the amount of copper is 3/4 the total weight. So if we know we have this much copper, our total weight has to be more than that. All right, so let's write an example or an equation where W is the total weight of the sample. And they've already done that for you. They say 3/4 times of means times the total weight, which we are looking for. That's why we call it W, equals, well, we know that there's 4 1/5 ounces of copper. Okay, so what we're going to do is ask ourselves, what is being done to W and how do I undo that? Well, W is being multiplied by 3/4. So to undo multiplying by 3/4, we would divide by 3/4 on both sides. So what does that look like? Well, 3/4 divided by 3/4. Anything divided by itself is 1 equals, then we have 4 1/5. 4 1/5 divided by 3/4 as well. Okay, well, remember dividing fractions. First make this into a mixed number, or excuse me, this mixed number into an improper fraction. So 4 times 5 would give me 20, plus 1 would be 21/5. Keep, flip my division to multiplication, and flop this to its reciprocal, so 4/3. Okay, and that's exactly what they're going to do here. They're just going to multiply by 4/3 right away. And that's because they're multiplying by the reciprocal. All right, in other words, times by 4/3. We did the same thing, just a little bit different fashion. Well, 3 times 4 is 12, and 4 times 3 is 12. 12 divided by 12 is 1. That's the same thing I got, 1W. Equals, and now let's simplify over here before I multiply. So divide each of these by 3. It would give me 1 and 7. Okay, 7 times, I skipped a step here, but we already did this. Write it as an improper fraction where the numerator is bigger than the denominator. And now let's get to multiplying. 7 times 4 would give me 28 over 5 times 1 would give me 5. Or, let's see, 5 goes into 28 5 times, which is 25. 3 left over to get to 28 and keep my denominator of 5. So the sample weighs 5 3/5 ounces. And that makes sense because 3/4 of this is 4 1/5 copper. Okay, today you just have one check it out problem. So please pause here and try the check it out. All right. For the last example, it says solve x minus 3/8 equals 7/8. So what number, when you subtract 3/8, gives you 7/8? So the way I'm going to tackle it is I'm going to ask myself, what's being done to x? Well, it's being subtracted by 3/8. How do I undo that? I add 3/8 to both sides. Negative 3/8 plus 3/8, those are opposite. They cancel out, and I'm left with x equals 7/8 plus 3/8. Super nice. I've got a common denominator. I'll keep it. And then 7 plus 3 gives me 10. And then I'll rewrite this as 8 goes into 10 one time, and there's 2 left over to get to 10. Keep my denominator. And I can simplify that as 1 and divide each of these by 2 will give me 1/4. Okay, so 1 1/4 will be your final answer there. All right, again, make sure you remember your integer rules. So For multiplying and dividing, it's same sign equals positive, different sign equals a negative. For subtracting, it's think about chop chop. So change your subtraction to addition and the next sign to its opposite. And for adding, the rules was same sign, add, and keep the sign, and different sign, find the difference. In other words, subtract them and take the number that has the greater absolute values sign, whether that's a negative or a positive. Okay, so try to remember all these integer rules. We're getting lots of practice with them. They're going to be repeated throughout your math career. And then also now apply our rules of fractions. So KFF, remember how to simplify, and getting a common denominator for adding and subtracting fractions. That does it for 3.8. This is the last lesson in Chapter 3. So I'll say good luck on your upcoming test. I will see you for Chapter 4.